Yes, my name is Nasari. Yeah, and we are doing mapping. So, mapping is a mechanism that maps a portion of a file or an entire file on a disk to a range address within application address space. So, direct mapping is, we have three types of mapping functions: direct, associative, and set associative. So in direct mapping, the cache consists of a normal high-speed random access memory. Each location in the cache holds data at a specific address in the cache. This address is given by the lower significant bits of the main memory address. This enables the block to directly be selected from the lower significant bit of the memory address. The remaining higher significant bits of the address are stored in the cache with the data to complete the identification of the cached data. Now the tags consist of higher significant bits of the address, and these bits are stored with the data in the cache. The index consists of the lower significant bit of the address. In set associative mapping, the cache is divided into blocks. The number of blocks in a set is known as associativity, or the set size. Each block in each set has a stored tag. A tag together with the index completely identifies the block. Thus, set associative mapping allows limited number of blocks with the same index and different tags. In fully associative type of cache memory, each location in cache stores both memory as well as the data. Whenever the data is requested, the incoming memory addresses are simultaneously compared with all the stored addresses using the internal logic and the associative memory. If a match is found, the corresponding is read out. Otherwise, the memory is accessed if the address is not found in the cache. This method is known as fully associative mapping approach because the cache data is related to the main memory by storing both the memory address and the data in the cache. Now we have replacement algorithms. So it specifies different ways to evict an item from the cache when it is full. So there are a bunch of algorithms available used in the different scenarios. So we have optimal replacement. The best algorithm is called the Biledes algorithm because it always discards an item from the cache if it is no longer needed in the future. Of course, this is theoretical and cannot be implemented in real life since it is generally impossible to predict how far in the future information will be needed. So we have the first in, first out, or last in, first out replacement algorithm. In this, the item that enters the cache first is evicted without any regard of how often or how many times it has accessed before. Now, last in, first out behaves in the exact opposite way. It evicts the most recent item from the cache. So the least recently used, which is LRU. Here we replace the item that has been unused for the longest time. Implementations is almost the same as the first in, first out cache. It used a map and doubly linked list. The only difference is that at any time there is a cache hit, we move it to the front of the queue. Items at the front are most recently used, and the items at the tail are the least recently used items. And when the cache is full, we remove the item that is at the tail of the queue and put the new element at the head of the queue. It also has consistent lookups, adds, and delete operations. Thank you. Yes, my name is